Today we're going to talk about reducing the risk of injury from belt conveyor components, both powered and non-powered components using guarding. Here's what I mean by powered and non-powered components. Conveyor belts have a risk of injury. That risk comes from the powered components, like the motor and how the motor transfers that power to the drive pulley. But it also has risk with non-powered components. And I think we overlook sometimes when we look at guarding rules and regulations from OSHA, MSHA, and other safety regulations, we think specifically about the powered components. In a conveyor belt, the non-powered components they really show us, they give us significant risk. And those non-powered components might be or would be any rolling component that meets the belt can create a pinch point, even though there's no power there, just because of the overall power on the system. Really, any pinch point, like at a tail pulley or a return roller, those are going to create pinch points. Those are going to create hazards, and those should be guarded. So, we're talking about applicable guarding, both powered and non powered components today. I want to show you this real quick. Some of you may have seen this before, some of you may not. But what this is plots out the reaction time compared to belt travel. So you've got some different colored bars on there going from left to right. You've got a black bar at the top, a blue at the bottom, and those represent different speeds of conveyor belts, some of the average speeds that we kind of work with. Black being one of the fasters, and blue being one of the slower conveyors. On the left-hand side, going from bottom to top, you see belt travel, and this is measured in feet. So you've got 2 feet of belt travel, 6 feet of belt travel, 10 feet, and so on. Bottom right, on the bottom, across, from reading to left to right, what you have is typical humans' reaction times, which what this means is that the time it takes your brain to send a message to your hand to tell the hand to drop a tool or to move out of the way because that hand's in danger. Now, we've measured reaction time over the years, and on average, we come up with a normal human having about 0.8 seconds of a reaction time. So, what that means when we plot that reaction time out with different belt speeds, it can tell us how far the belt will move in distance in the time it might take us to move our hand away. So the faster the belt's moving, the more distance it's going to travel in that 0.8 seconds. So if I had a belt that was traveling at 400 feet per minute, represented by this line right here, and my reaction time is 0.8 seconds, that tells me that that belt's going to travel about 5 foot before my brain can tell my hand to drop a tool. So if you haven't seen this before, it's pretty interesting. It's something that you should share with your staff so they kind of keep it more top of mind and how at risk they are and how unlikely they are to drop a tool if the tool was stuck in a pinch point. So mines, facilities, they have to invest in safety. And really, there's kind of 3 ways that you can invest in safety. You can add guarding to protect the worker, or you can pay the citations that come along without guarding properly, or you can pay the litigation fees that might come along with contesting improper guarding technique or an injury. So it's kind of take your poison here on where you want to spend your money. You can spend the money in an excellent guarding effort to protect workers, or you can spend your money in the citations that come along from not having an excellent guarding strategy, or you can pay the money in the litigation fees that might come about from trying to contest, or if you have the unfortunate event of an accident as well. So let's give you a little bit of minimal guidance on what we need to do to guard a conveyor properly. And I say minimal guidance because OSHA, MSHA, if you're in the US, OSHA and MSHA kind of govern where we're at on conveyor guarding. And OSHA in particular refers to 1926 and 1910. And I don't know, I don't recall which one's which. Somebody might be able to help me out with this, but one is construction and one is general industry. But basically, whether you're in construction or general industry, the guarding recommendations is kind of unclear. It doesn't really give you the specifics on how to guard. Now, their guidance on what you need to do is excellent. You know, we need to know that we're guarding against the moving parts, and they must be inspected, and they must prevent accidental contact with moving parts. All that I very much agree with, but the actual execution of how to do those things is what we're going to cover today. And MSHA has very similar regulations. Those regulations can be found in 56, 57, and also 77, 75, depending on whether you're coal and then underground or surface, and then if you're non-metal, underground or surface mining. But basically, the regulations are kind of the same. Moving parts of conveyors, including belts and pulleys, must be guarded to prevent miners from coming into contact, and those guards must have regular inspection and maintenance. So we're going to talk a little more specifically about that. OSHA refers also to an ANSI standard. ANSI B11.19 Clause 8 gives some more specifics on conveyor guarding, and they're looking to kind of maybe update this. Last I've heard from ANSI, we'll see if that happens or not. But I don't need to necessarily go through each one of these for you because they're kind of vague. But 8.1 gives general requirements. 8.2 speaks to the strength and the durability of the guard. 8.3 talks about how the guard shouldn't obstruct maintenance of the machine, and that could be a challenge. We'll talk a little bit more about that. 8.4 adjustability to guards. 8.5 stability. We want to make sure that they are not displaced during operation of the machinery. 8.6 speaks to interlocking. 8.7 talks about light curtains, which is some of the new technology out there. And then also maintenance and inspection and those types of things. So here's what this means. Here's what B11.19-2019 means. If for some reason you were to find yourself in a position where you had to litigate a guarding citation or an injury, um, OSHA would refer to this B1119 standard. And typically, they're expert witnesses that might provide some expert testimony in litigations would be um, engineers from ASME. And ASME is the group that writes these ANSI standards. So that's kind of why I wanted to share that with you. So let's talk some of those nuts and bolts on conveyors. First thing is we want to make sure the guard's not a hazard itself. And the concern that we have is a lot of facilities oversize their guards and just make big, large panels, which are very difficult for a worker to remove or to add or to replace. We want to make sure that that guard's about 50 pounds or less. We really want to make sure that there's nothing that's going to actually hurt the worker as they move that guard. Some more specifics. 50 pounds or less. You want to make sure there's no sharp edges, and if the guard's hinged, you want to be concerned about the hinges or the pinch points that those hinges might create. If you look at the photo that I've shared with you in this particular example, that guard's sized correctly. It's easy for one person to handle. There's no hinges. And what is nice about in this example is that there's handles that make it a little bit easier for that worker to remove and then eventually replace that guard. So we don't want guards snagging clothing, snagging skin, cutting someone, causing back strains, things like that. Okay, we use this acronym AUTO, A-U-T-O. You might want to jot that down. You might want to share that with your staff. That's just a quick little reminder that we don't want to create guards that a worker can reach around, under, through, or over a guard. So if you look at these photos, this photo on the left was one that I took at an aggregate facility in the Midwest several years ago. And in this photograph, they were guarding their tail pulley. And I asked the guys at the facility what's going on with this hole in the guard. And they said, well, we needed to cut that opening to get our arm in there to clear material out. So it's not what that's for, gang. You got to make sure that those guards are installed where a worker can't reach through, around, under, or over. Photograph on the right is at a cement plant. And as I was going up these steps, they were pretty proud of their guarding, and I give them credit. They made an attempt. They guarded the moving parts. They met the letter of the law. But it's really those specifics on guarding that we have to be uh, aware of. And they really missed the boat on the specifics because in this example, a worker could certainly reach around that guard. So we've got to make sure that we're we're not allowing workers to reach over, around, under, or through a guard. Okay, the guard should stand out in color. And one of the concerns that we have is the yellow painting of guards. Typically, yellow is recognized as safety color. It's high visibility. The concern with yellow is it does not allow the maintenance or an inspection to be done just by looking through the equipment. If you look at this photo, nice looking guard, well constructed, stands out in color, but that yellow makes it difficult to do a visual inspection of the equipment behind it. So what a lot of facilities are doing now is they're painting the border of the guard yellow, but the field of the guard black. And if you look at this photo, this kind of shows you what I'm talking about. On the right hand side of this photo, we can clearly see that that is a carrying idler. Like there's no question that that idler is a troughing idler or a carrying idler on the upper side of the conveyor. We can see pretty easily that those rolls look to be worn evenly. So that tells us it's making good contact. We can see pretty easily that that's probably about a 35-degree trough. If I was doing a visual inspection here, I could probably tell you pretty easily if I could see if those rolls were turning or not. I could see easily if there's any material built up. So because there's no yellow in front of that. But on the left-hand side of the photo, where that guard is painted yellow, if I were to look at this idler, it's very, very difficult to even tell that there is an idler there, let alone being able to inspect it to see if it's worn properly, to see if it's built up with material, to see if there's any damage. So the guards must stand out in color. They cannot be painted the same color as every other piece of equipment, but you also need to make visual inspections as easy for your workers as possible. And one way to do that is to paint the frame yellow and the field of the guard black. Another example, all yellow, certainly identifiable as a guard, stands out in color, however, very challenging to do a visual inspection of the equipment that it's guarding. Guard must also be the proper distance from the hazard. So what we're looking at with this is the size of the guard opening and its proximity to the rotating piece of equipment. If that guard opening is rather large, then that guard needs to be further and further away from the rotating piece of equipment. If that guard is installed very, very close to the rotating piece of equipment, then the opening in that guard must be much, much smaller. And ANSI makes a guard gauge. Some manufacturers call it a gotcha stick. We call it a guard gauge, but you can see this worker in this photo using that guard gauge as an indicator to whether or not those opening sizes are satisfactory compared to the distance that that guard is from the rotating piece of equipment. Okay, this is an important one and a complex one. OSHA says that the guards must require a tool to remove. MSHA does not say that. MSHA says that the guards must be securely fastened. So there's some deviation there between the two organizations. If you're not governed by OSHA or MSHA, if you're outside of the U.S., and even if you're governed by MSHA, I would strongly recommend that you use this OSHA standard, simply because it's the highest threshold of safety out there. And that says that the guard must require a tool that the worker typically does not have on him to remove the fastening system on the guard. So that's what you see in these photos. On the photo on the left, the worker would need a wrench to remove that nut, to remove the guard. Photo on the right seems to be a little more complex, as they've used zip ties fastened through those openings to secure that guard. Um, so that's a tough one. Um, Zip ties over time become brittle, and as they become brittle, they're not strong enough, and a worker can simply pop them with their hand. The other thing too is that if the zip tie is undersized, then it might be able to be bypassed by a worker without a tool. Your facility's at risk for that. So we're not a big proponent of zip ties. There's better ways to do this, better ways to secure the guard than using a zip tie. If they were well maintained, well inspected, and never corroded over time, they'd be acceptable. But that's simply not the case with zip ties. Couple of examples of fasteners that you can kind of see out in the marketplace. The fastener on the left rotates down. There's some spring steel that you would squeeze together right here. So that's a very thin spring steel. You squeeze that, and that allows this unit to pivot on that pivot point right there. And then as that guard pivots down, it makes it a lot easier to take that guard or secure that guard. Kind of the same thing with the photo on the right. This thing can kind of lock in a little bit, causing that to stick straight out, and it makes that guard a little bit easier to remove and then replace that guard. As the equipment's in operation, you'd leave that clamp down like that, and then you probably should put, because we want to satisfy the tool requirement, you should put a nut and a bolt through that, maybe even a small little padlock, depending on the level of security or the level of safety you're trying to achieve there. Okay, guards must be inspected and maintained, and that's if you recall earlier, the ANSI standard and OSHA and MSHA, the guarding regulations both speak specifically to maintenance of guards. And in our field experience, we see this all the time. A facility guards a piece of equipment, and that's it. They're done with it. There's no plan to routinely inspect it or to maintain it. It's like they think of it as a one-time investment. And unfortunately, that can't be the case with guarding. We have to make sure it's included in routine maintenance inspections and gets replaced or repaired as it needs to be replaced or repaired. So you want to make sure when you're inspecting guard, you want to make sure that first and foremost that the guard is attached properly, because workers do tend to not reattach the guard properly after it's been removed to do some work. So they should be inspected maybe monthly to be sure that they're securely attached or reattached. You want to inspect for wear on the guard or deflection of the guard, like you see in this photo. Expanded metal like this, those welds can break. That guard then deflects away from its frame, and that's not an effective guard. You want to make sure that they are repaired and replaced as needed, and you want to make sure you train your workers to ensure that they're reinstalling those guards properly after they might have to remove them to do some work. Okay, we need to talk specifically about return roll guards because they have a little bit different application, and there's some things that we need to share with you real quick here on return roll guards. And the first is that they do create pinch points between the belt and the roller. And if that pinch point is less than 7 foot in elevation, then that pinch point must be guarded. Now, MSHA considers that any pinch point that is less than 7 foot in elevation is considered guarded by location. So, what they mean by that is that a worker can't access that pinch point. But a couple of things you've got to be aware of. If if you're allowing material to build up underneath a conveyor belt, that pile of material may change the 7 foot distance to the return roll. The other thing that you got to be aware of is on some conveyors that don't have a catwalk on them, and you're accessing them by with a man lift. If that worker hasn't locked out and tagged out that conveyor belt, and they're maybe doing some other work on that man lift near that, once they're below that 7 foot threshold, then that pinch point is no longer considered guarded by location. So you got to pay close attention to that. In addition to return rolls that are less than 7 foot in elevation, any return roll, regardless of its height, must be guarded with a catch basket if that return roll is over a roadway or a walkway. I took a call, it's maybe been a year ago now. A worker called me. He was at a grain handling facility on the Mississippi River, and one of their return rolls fell and struck a worker who was standing underneath it. Now, it just caught this worker's shoulder. So, fortunately, this worker didn't really get injured. But if that belt mistracks and wears into the bracket that holds the return roll, that return roll could fall unexpectedly, and that's happened. And for that reason, if that conveyor belt is over a roadway or a walkway, you've got to have a catch basket or something to catch that roll if it were to fall. Now, you've seen people use netting and things like that. I think that's okay, except that, again, that net is somewhat similar to um, zip ties in that it might get brittle, it might deteriorate with the elements, and the security and confidence that you have in a basket is much greater. Real quick review of the things that we talked about here. Guards can't be a hazard itself. Remember this acronym of A.U.T.O. That's really important to share with your staff. They need to stand out in color. Don't have to be yellow, don't have to be orange, but need to be different color than the equipment. We talked about the proper distance using that gotcha stick or guard gauge, securely fastened, hopefully with a tool, and then make sure you maintain them and inspect them. And boy, don't forget about those special considerations that are so important for return rolls. Don't overlook the hazard that those are. A couple of additional resources for you that you might want to take a look at. OSHA has a publication 3170. It's called Safeguarding Equipment and Protecting Employees from Amputation. Also, MSHA Guide to Equipment Guarding, and as well guarding machinery in metal, non-metal minings. That's a little bit dated, but it's pretty good stuff. I would take a look at it. If you've not, you can get both of those on OSHA or MSHA's webinar. And then if you've not heard of SEMA before, I would strongly suggest that you take a look at SEMA.net, SEMAnet.org. But ultimately, we feel the best resource is our Foundations book. Thanks for joining us today. Take care, everyone.